In this video, I'm going to go through some problems in limits. The first question is to evaluate limit of x going to 4 of 2x cubed minus 128 over square root of x minus 2. When we are dealing with fractions, especially with the square root in the numerator or denominator, we have to try to eliminate the denominator. To eliminate the square root, we are going to use the conjugate. So I'm going to multiply the numerator and denominator by square root of x plus 2. So this becomes limit of x going to 4 of 2x cubed minus 128 times square root of x plus 2 over square root of x minus 2 times square root of x plus 2. The denominator becomes, because it's square root of x minus 2 times square root of x plus 2, I'm going to use the difference of squares, so this becomes x minus 4. A squared minus b squared. Now the numerator, I can factor 2 from 2x cubed minus 128. So this becomes 2x cubed minus 64 times square root of x plus 2. By definition, x cubed minus 64 can be written as limit x goes to 4 of 2 times x minus 64 is 4 cubed, so I can write it as x minus 4 times. Remember, in review or getting ready for unit 1, we said that x exponent n minus a exponent n can be written as x exponent 2 times 4 exponent 0 plus x exponent 1 times 4 exponent 1 plus x exponent 0 4 exponent 2. Remember, the exponents, the sum is always n minus 1. N is 3 here, so it's 2 times square root of x plus 2 over x minus 4. This is the same as the limit of x going to 4 of 2 times x minus 4. 4 exponent 0 is 1, so I get x squared. 4 exponent 1 is 4, so plus 4x plus 16 times square root of x plus 2 over x minus 4. X minus 4, they cancel each other out. So this is really substituting x equal to 4 in this fraction. We get 2 times 4 squared is 16 plus 4 times 4 is 16 plus 16 times square root of 4 is 2, so 2 plus 2, which is the same as 2 times 3 times 16 is 48 times 4, which is 8 times 48, and 8 times 48 is going to be 384. The next question says, find the value of k for which the following limit exists, and also if the limit exists, find the limit. First, I'm going to, since I'm dealing with a fraction, I'm going to factor out the denominator. So this is 4x squared plus kx plus 7k minus 6. Now the denominator, the leading coefficient is not equal to 1, so I have to use the decomposition method. We know that A is 2, B is negative 5, and C is negative 3. So AC is equal to 2 times negative 3 is negative 6, and B is equal to negative 5. Now we are going to find two numbers with the sum equal to negative 5 and the product negative 6. Those two numbers are negative 6 and 1. So the middle term, negative 5, can be decomposed into negative 6 plus 1. So I can write the denominator as 2x squared minus 6x plus 1x minus 3. Now I take these two terms and these two terms. From the first two terms, I'm going to factor out 2x. So I'm going to get x minus 3 plus, and the last two term is x minus 3. X minus 3 is the same, so I can factor x minus 3, and I get 2x plus 1. So the denominator becomes x minus 3 times 2x plus 1. Now, since the limit has to be found when x goes to 3, in the denominator, the factor x minus 3 is the problem, because x minus 3, when the limit goes to 3, becomes 0, x minus 3. So I have to find k such that the numerator can be factored into x minus 3 times some other factor. So I'm going to use long division, and I'm going to divide 4x squared plus kx plus 7k minus 6 by x minus 3. So I'm going to say 4x squared plus kx plus 7k minus 6 divided by x minus 3. So the first one is going to be 4x, because 4x times x minus 3 gives me 4x squared minus 12x. Changing the sign, 4x squared minus 4x squared gives me 0. So I get kx plus 12x. So I'm going to get k plus 12 times x plus 7k minus 6. Now, to get rid of k plus 12x, I'm going to multiply this by 7 plus k plus 12. So k plus 12 times x gives me k plus 12x, and k plus 12 times negative 3 gives me negative 7k, negative 3k, and negative 3 times 12 is negative 36. Now I change the sign. This is negative, this becomes positive, and this becomes positive. This cancels with the previous one. 7k plus 3k gives me 10k. Negative 36 plus 36 gives me plus 30. And I'm done with the division, because the remainder doesn't have any more x. So I can write this one as limit of x goes to 3. 4x squared plus kx plus 7k minus 6 can be written as x minus 3 times 4x plus k plus 12 plus 10k plus 30 divided by x minus 3, 2x plus 1. Now, if I separate this limit, I can write this one as limit of x goes to 3 of x minus 3 times 4x plus k plus 12 divided by x minus 3 times 2x plus 1 plus limit of x goes to 3 of 10k plus 30 divided by x minus 3 2x plus 1. Now x minus 3 goes with x minus 3. The problem is this part, and because when x goes to 3, the denominator is still 0. So to make sure that the limit exists, we need to make sure that 10k plus 30 is going to be 0. So 10k plus 30 has to be 0. So from here I get k has to be negative 30 over 10, which is negative 3. So if k is negative 30, this fraction is going to become 0, and this fraction is going to become limit of x goes to 3 of 4x. If k is negative 3, so it becomes 12 minus 3 is going to be 9 over 2x plus 1. Now I can safely let x go to 3. If x becomes 3, then we get 4 times 3 plus 9 over 2 times 3 plus 1. So 4 times 3 is 12 plus 9 is 21 divided by 2 times 3 is 6 plus 1 is 7. So the limit becomes 3. So if k is equal to negative 3, then the limit exists and the value of the limit is equal to 3. The next question is asking us to determine the following from the graph. Limit of x goes to negative 1 from left. When x goes to negative 1, which is here from left, we know that we have to go along this graph here. When we go toward negative 1, the value of limit becomes 3. The value of the limit going to negative 1 from right, here. If we go to negative 1 from right, we have to follow this curve. When we go to negative 1 from the right, the value of the limit becomes here, which is 0. The value of the function when x goes to negative 1, you can see that when x goes to negative 1 from left, we get 3. When x goes to negative 1 from right, we get 0. So the limit does not exist. So there is no limit if x goes to negative 1. The value of the function at negative 1 is this one here, because this is filled circle. This is part of the graph. So the answer is 3. The next one is the value of the function when x goes to 1 from left. When x goes to 1 here from left, we have to follow this graph. You can see easily that the limit is 2. The value of the function when x goes to 1 from right, we have to follow this graph. When we go to 1, the value of the function is 2. the limit of the function when x goes to 1, since the left and right limits are equal, the value of the function becomes 2. Now it asks what is the value of the function f at 1. You can see it's a whole, so it doesn't exist. Now the limit of the function when x goes to 3 from left. So I have to go this way, and we can see that the value of the function is 0. Now the value of the function when x goes to 3 from right. So I have to go this way, and the value of the function is 0. Now it says the limit of the function when x goes to 3, because left and right are equal and equal to 0, so this is equal to 0, and the value of the function when x is equal to 3 is 0. The next example is asking us to find the interval where the following function is continuous. Or we can say we have to find the domain of this function. To find the domain of a function which is composed of individual functions, we can find the domain of individual functions and then find the common region. So we are going to start with this function first. So let's look at 1 over x. The domain of this function, call it d1, is x such that x has to be in real numbers and x cannot be equal to 0. That's the domain of the first function. The domain of the second function, which is this one, square root of x plus 6 over x squared plus 1. First of all, we are dealing with the fraction. So we have to make sure the denominator, which is x squared plus 1, is not 0. X squared plus 1 is never 0. The reason is that x squared is going to give us a positive number, and a positive number plus 1 cannot be 0. So we can't have the situation that we are dividing a number by 0. The other condition is that x plus 6 over x squared plus 1 has to be greater than 0. This, since x squared plus 1 is always greater than 0, so this means that x plus 6 has to be greater than 0. So if I move 6 to the right, I get x has to be greater than negative 6. So the domain of this one, call it d2, is equal to x such that x is in R and x has to be greater than negative 6. And also it can be equal to negative 6, because if it's negative 6, then this becomes 0. So all these inequalities, they change to greater than or equal to negative 6. The next one is 3x squared plus 5. We know that 3x squared plus 5 is a quadratic and the graph is a parabola, so this means that d3 is x such that x in R and there is no restriction. This is true for all real numbers. And the last one is the sine function, sine x. If you remember from last year, sine function looks like this graph going from left to right, and there is no restriction on the x-axis. So d4 is x such that x in R. Now if we look at the number line, and we draw these regions, the first one says x cannot be 0. So this is the first one, a hole, and everything on the x-axis is accepted. The next one says x has to be greater than or equal to -6. So including -6 here, everything here is accepted. The next one is x in R, and the last one x in R. So you can see that our domain, the final answer, is x such that x in R, x has to be greater than or -6, and x cannot be equal to 0 because of this condition. The next question says, find the equations of the tangent lines to the following curve at points a, 0, -1, and 4, and 3/5. If function f of x is x minus 1 over x plus 1. To find the tangent line, we need the slope. To find the slope, we need the rate of change. So we are going to use the quotient difference formula to find the rate of change of the function with respect to x. So I'm going to write delta f over delta x is equal to limit of h goes to 0, f of x plus h. So it's going to be x plus h minus 1 over x plus h plus 1 minus f of x minus x minus 1 over x plus 1 over h. To simplify this fraction, I'm going to try to make the denominators the same. So this fraction, I'm going to multiply the numerator and denominator by x plus 1. And this fraction, I'm going to multiply the numerator and denominator by x plus h plus 1. So this becomes limit of h goes to 1 of x plus h minus 1 times x plus 1 over x plus h plus 1 times x plus 1 minus the second one. I'm going to multiply numerator and denominator by x plus h plus 1. So it's x minus 1 x plus h plus 1 divided by x plus 1 times x plus h plus 1 divided by h. Now I'm not going to go through the multiplication of all these binomials and trinomial. The final result, after you do the simplification of the numerator, is going to be limit of h goes to 0 of 2h over h times x plus 1 times x plus h plus 1. Since h is common in the numerator and denominator, I can cross it out. Now I don't have any h in the denominator, which causes the denominator to become 0 when h goes to 0. I'm going to find the limit by just substituting h equal to 0 now. So it becomes 2 over x plus 1 times x plus h is 0, so 1 plus 0 is 1. And when x goes to 0, when h goes to 0, the slope or the rate of change becomes 2 over x plus 1 squared. So this is our slope now. Knowing the slope, we look at point A first. I can write the equation of the tangent is y is equal to mx plus b. Since the x value of point A is 0, the slope becomes 2 divided by 0 plus 1 squared, which is 2. So it becomes 2x plus b. But since it also goes through the point A, it has to satisfy point A. So we can write that negative 1 is equal to 2 times 0 plus b. So b is equal to negative 1. So from here I get y is 2x minus 1. So this is the equation of the tangent at a equal to 0, negative 1. Now to find the equation of tangent at point B, which is 4 and 3 over 5, I do the same thing. I'm going to say that the slope here is going to be 2 over x is 4, so 4 plus 1 is 5, squared is 25. So my line becomes 2 over 25x plus b. Again, it goes through this point, so I sub it back in the equation to find b. I get 3 over 5 is equal to 2 over 25 times x. X is 4, so times 4 plus b. Now, 3 over 5 can be written as 15 over 25. You multiply numerator and denominator by 5, so this becomes 15 over 25. I move this one to the left. 2 times 4 is 8, so minus 8 over 25 is equal to b. So b becomes 7 over 25. So my equation becomes y is equal to 2 over 25x plus 7 over 25. The next question says, a particle moves in a straight line along the x-axis. The displacement is given by the formula s of t is equal to t cubed minus 4t squared plus 7t. If the displacement is in meters and time in seconds, we are supposed to find the average velocity over the time interval 4 and 7, and also the instantaneous velocity at 4. So to do the average, we are going to use the time intervals, which is between 4 and 7. So I'm going to say that delta S over delta T is S7 minus S4 divided by 7 minus 4, which is equal to 7 cubed minus 4 times 7 squared plus 7 times 7 minus S of 4 is 4 cubed minus 4 times 4 squared plus 7 times 4 divided by 7 minus 4 is 3. If you do the division here, we are going to get 56 meters per second. So the average velocity over the time interval 4 and 7 is 56 meters per second. Now the second part says find the instantaneous velocity at t is equal to 4. To find the instantaneous velocity, I'm going to use the difference quotient to find the limit when h goes to 0. So I'm going to find delta S to delta t at t equal to 4 is the same as 4 plus h cubed minus 4 times 4 plus h squared plus 7 times 4 plus h minus 4 cubed minus 4 times plus 4 times 4 squared minus 7 times 4 divided by h. If we simplify this one, limit t goes to 4 is the same as limit t goes to 4 of 4 plus h cubed minus 4 times 4 plus h squared. And if it's 4 cubed negative and 4 times 4 squared, which is 4 cubed, they cancel each other. If we expand 7 times 4 plus h, it's going to give us 7 times 4 is 28. It goes with this negative 7 times 4, and then we're going to end up with 7 times h. So it's going to be plus 7h divided by h. Now, if we use Pascal's triangle to expand 4 plus h cubed, we are going to get this is equal to limit h goes to 0 of 64 plus 48h plus 12h squared plus h cubed. If we expand this, remember the Pascal triangle is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Remember the first row is 0, then 1, then 2, and then 3. We need row 3 because this is cubed, and these are the coefficients of each term, 1, 3, 3, 1. If we use the Pascal's triangle and multiply the coefficients, we get 64 plus 48h plus 12h squared plus h cubed. And then 4 plus h squared is going to give us 4 squared plus h squared plus 2 times 4 is 8h. And then you multiply negative 4 by each term, we get negative 64 minus 4h squared minus 32h, and then we have a 7h here at the end, divided by h. This is the same as limit h goes to 0. If we simplify this one, we have only 1h cubed. Then we have 12h squared, negative 4h squared, so it gives us 8h squared. 64 and negative 64, they cancel each other out, so 48h minus 32 gives us 16h plus 7 is 23h divided by h. Now h can be cancelled out, so this h goes with this h with the exponent, and this becomes 2. So this becomes limit of h goes to 0 of h squared plus 8h plus 23. Now when h goes to 0, this becomes 0, this becomes 0, so this becomes 23 meters per second. So that's the instantaneous velocity at t equal to 4.